The question says that a small candle 2.5 centimeter in size is placed at 27 centimeter in front of a concave mirror of radius of curvature 36 centimeter. At what distance from the mirror should a screen be placed in order to obtain a sharp image, and describe the nature and size of the image? If the candle is moved closer to the mirror, how would the screen have to be moved? So in this question, a concave mirror is given of a defined curvature, radius of curvature, and the object distance from the pole of the mirror is given, that is 27 centimeter, and the height of the object is given, that is 2.5 centimeter in size. At first we have to find out at what position should the screen be placed so that we can obtain the sharp image. So in a simple terms, it is asking the position V of the image from the mirror. And the second question is saying that describe the nature and size of the image. And the third question is, if the candle is moved closer to the mirror, how would the screen have to be moved? So the third question is saying that if we move this candle towards the mirror, then how would the position of this image? So let us proceed. So we can use the mirror formula over here, which is given by 1 by f equals to 1 by u plus 1 by v, where f is the focal length and u is the object distance and v is the image distance. So focal length of this mirror is given, that is of 36 centimeter by 2. So we can find out the focal length as 18 centimeter. Object distance is given, since it is in front of the mirror, so u is going to be negative, and it is going to be negative of 27 centimeter. So using this formula, we can calculate the value of v, because only v is unknown over here. So after we get the value of v, we can use it in the formula of magnification. So magnification we will get by minus of v by u, where v is the image distance and u is the object distance. So let's calculate the value of v first. So substituting the values of u and f in this equation, we get the value of v, that is v equals to minus of 54 centimeter. That is, the position of image is in the same side of the mirror as that of the object, because it is negative in size. Now we can negative in magnitude. Now we can calculate the value of m, that is minus of v by u. So substituting the values of v and u in this formula, we will get a value of minus 2, that is, the object is magnified and it is real. We can also see from the image diagram over here. So the at first we have taken the parallel to the principal axis, the array parallel to the principal axis, which is reflected passing through the focus, and the second ray is taken passing through the center of curvature. So it will retrace the incident ray, and since two ray must meet to form an image, so the image will form over here with a value of v equals to minus of 54 centimeter. Now we have got the value of v, that is where should the screen be placed. We have to find out what is the nature and size of the image. So since we have got the value of m, we can find out the we can find out the size of image, that is equals to magnification times the original size of the object, that is 2.5 times 2, that is 5 centimeter. And nature is real, the image is real. And now we have to find out, if the candle is moved closer to the mirror, how would the screen have to be moved? So that is, if this candle is approaching f and also approaching pole, then how would the position of image be moved? So let us make the diagram over here. So at first case, we assume that the candle has been placed at focus. So we see that these two rays have become parallel. So the image will be forming an infinity. So we can say that if the candle is moved towards the focal length, the position of image will be towards infinity. And if the candle is moved beyond f towards the pole, so we can see that the image is forming, that is virtual. No real image can be formed over here, and it is virtual and it is magnified. Thank you.